wondered why massive skyscrapers don't sink into the ground? Today, we're uncovering the hidden engineering logic beneath the surface.
Foundations are the invisible pillars that transfer weight safely into the earth. Without the right foundation, buildings can tilt, crack, or even collapse. Shallow foundations are used when the surface soil is strong and stable. Spread footings act like snowshoes, spreading the weight across a wide area. Raft foundations act like a giant floating platform, distributing weight evenly.
But what happens when the topsoil is weak? We must go deeper.
Deep foundations, or piles, are driven down to reach solid rock layers.
The process starts with excavation, removing soil to the exact engineering depth. Next, steel reinforcement is placed to handle tension and stress.
Then comes the concrete pour, forming the solid base structure. Curing is critical. The concrete needs days to gain its full strength. But poor soil or simple mistakes can cause catastrophic failure.
To prevent this, engineers calculate exactly how loads travel through the building. Engineers verify the load path, from the roof, down the columns, to the foundation. The foundation's job is to spread this heavy load so the soil doesn't fail. Think of it like wearing flat shoes on mud versus high heels. Surface area matters. All buildings sink slightly over time. This is called settlement.
But if one side sinks faster than the other, that is catastrophic.
So, what happens when the topsoil is too soft, like near a river? We use friction piles. These rely on the grip of the soil against the pile surface.
Or end-bearing piles, which act like underground columns resting on solid rock. Drilling these requires massive rigs that bore down 50 meters or more. A steel cage is lowered into the hole to give the concrete tensile strength. Concrete is pumped from the bottom up using a tremie pipe to push out groundwater. Once cured, these piles are locked together by a massive concrete cap. This cap becomes the base for skyscrapers weighing hundreds of thousands of tons. But foundations have a sworn enemy: water. If the water table rises, it creates hydrostatic pressure against the concrete. This is why engineers apply thick, bituminous waterproofing layers. In earthquakes, wet, sandy soil can turn into liquid. This is called liquefaction. This phenomenon causes entire buildings to tip over, even if the structure is strong. To prevent this, we perform deep soil testing before a single shovel hits the ground. Construction starts with precision surveying. Every millimeter counts. Excavators carve out the earth to the exact depth required by the blueprints. Iron workers tie thousands of steel bars by hand to create the skeleton.
Formwork is installed to mold the wet concrete into shape. Then the pour begins. It must be continuous to avoid weak spots. Vibrators are used to release trapped air bubbles that would weaken the structure. Once solid, the concrete must be kept wet for 28 days to reach full strength. We verify this strength by crushing sample cubes in a lab press.
Ignoring soil conditions is the #1 reason foundations fail. If steel is too close to the edge, moisture gets in, causing rust that bursts the concrete.
And adding too much water to the mix makes concrete weak and brittle. From simple homes to massive dams, the principles remain the same.
The foundation is the silent hero. It carries the weight.
It is the most expensive part of a building you will never see.
If you want to understand the world around you, in the next episode, why do concrete beams crack?